Welcome, this is Group 3's IIR filtering assignment video. The project was to create an EOG device which can measure eye movements to control a digital keyboard. This project is designed for people who have severe mobility and dexterity disabilities such as ALS. Now a background on EOG. The main concept of EOG is to use the polarity of the eyes to detect the eye position. The front of the eye, the cornea, is slightly positively charged, whereas the rear, the retina of the eye, is slightly negatively charged. So, if we place two electrodes near the eyes and the user looks to the right, the green electrode, in this case the positive electrode, will see a slight positive charge, whereas the red electrode, the negative electrode, will see a very slight negative charge. We can then measure the potential difference between these two electrodes to determine that the user is looking to the right. Let's talk about the digital keyboard. On the right here is an example of a keyboard made in Python. And this keyboard has all the letters of the alphabet split into 3 characters, including an underscore which represents the space between words. The user has 3 choices. They can look right, they can look left, or they can blink. Examining the EOG signal of these 3 choices, you can use thresholds to determine the choice the user has made. So, if the user wants a letter from A to I, they can look left. And then that category will be broken into 3 subcategories. If the user wants letters A, B, and C, they can look left, and that category will be broken down into the letters. And if they want the letter A, they can finally look left again. This means that the user would only need to pick 3 options in order to get their final letter. Unfortunately, due to time constraints, we were unable to implement this keyboard in the final EOG design. Let's look at the initial setup. Here we have a user wearing a custom-made headband with embedded electrodes. As we can see in this image, we have an electrode next to the right eye, which is connected with a green wire that connects into the positive terminal of the amplifier box. In the center of the forehead is a ground electrode that connects with a black wire to the ground of the amplifier. If we look at the left side of the user, we can see there's a red wire that connects to an electrode next to the left eye. This is connected to the negative terminal of the amplifier. The amplifier has been secured in a scarf to prevent movement artifacts. Here is the output screen from our Python code. The top left graph is the raw data from our EOG signal. The lower left graph is the filtered signal. Next to these graphs, we can see the terminal, which is currently printing out the word center to indicate that the user is looking straight ahead. If the user looks right, the word right will be printed into this terminal. If the user looks left, the word left will be printed into the terminal. Let's bring in the user.
Now look left and look right and look left and right and blink. Blink again.
At the end of the video, we saw blinking. This is caused by artifacts created when the facial muscles move. Forceful blinking creates a large peak on the graph, which when set with an appropriate threshold can be differentiated from looking right and from natural blinking. Thank you for watching.